Going. Welcome back to another Leetcode Daily. Today we have a lowest common ancestor of deepest leaves. Um, in this question, the description is really kind of confusing. Took me a long time to understand, but basically, it wants the lowest common ancestor of the deepest leaves. So basically, figure out the deepest leaves. It wants the smallest subtree you can form from the deepest leaves. It just wants you to return the root, and it's actually similar to this problem, which is it's called smallest subtree or whatever. Um, okay, so it says the node of the binary tree is a leaf if it has no children, obviously. The depth of the root is 0, and then as you go, you add 1. And then it says the lowest common ancestor of a set S of nodes is the node A with the largest depth, such that every node in S has a subtree with root A. So basically something like this. You figure out that 7 and 4 are the two largest, like this is the largest depth of 3. You just group them until they intersect to find its root and return that, basically. So this question has an intuitive solution, but it looks ugly. The intuitive solution definitely looks ugly, but that's what my thinking process was, and it was simply I don't know the max depth, right? So I calculate the max depth first, right? And then I thought, okay, so let's say the max depth here is 3, right? And then every time I do another DFS, and every time I figure out that some root node led to a max depth, I just add 1 and return, and then the maximum number of times a node has seen max depths is the answer, basically. So, for example, let's say we have this tree over here, right? We have a depth of 3, right? So basically, I run it first. I know the depth is 3 now, right? And then every time I run it again, and every time I figure out there's a depth of 3, so this root right here, right? DFS it, and then I figure out, oh, I reached depth of 3 here, so I return 1 from this one, for example, from the 7. I return another one from the 4, and then I realize, oh, 2 has 2 children that both lead to depth, and the maximum I've seen so far is 2 depths, right, at this right node right here. So I update the root to 2, basically. And then I return to 5, and and then I just return, basically. Like that's the intuitive solution. It kind of looks ugly because there's cases where basically there is not. So basically something like, forget the 4 exists, right? If the 4 does not exist, the answer is going to be 7, because the 7 is the smallest subtree you can form because it's itself. So there's none under it, and it's enough as a root, as an ancestor of a subtree. It's just a base case. It's an ancestor of a subtree, but it's just because it has no children. If you know what I mean. So basically, what the approach I made was, first of all, I DFS'd here, and then I just kept figuring out the maximum depth. The maximum depth is of this tree, and then I have it here, right? And then if there isn't, I just return the answer. If it's 0, I don't need to move forward, because then that means there's only one value in the tree anyways. And I have these 3 global pointers. And these 3 global pointers are going to be set accordingly, according to how many times I've seen them or whatever, right? So basically, this DFS function, it takes in the current depth and it takes in the node, right? If there's no node, I return 0, but this is the base case. But if I reach that current depth, I return 1. So basically, if I'm DFSing and I reach the 7, I don't even need to keep continuing. I just return 1 because I've seen the depth. Because I know this is the maximum it is anyways from the one above, right? So I turn 1, and then I iterate left and right, and then I add them together. So for example, this 2 gets the 7 and the 4 added together, and then I look at current max C, which is set to 0. If it's greater than it, I set it, and then I do this little if statement, because if the current max scene is 1, that means that the maximum depth might be only once, like 7, for example. So 7, if there's no 4, 7 is the maximum there is, there might not be anything else. So it's 1 anyway. So just set it to that, to the 7. Don't set it to anything else. Basically, this is what this line does. Otherwise, set it to the current node, which is the root that received the left and right. Right. Yeah, basically, and I call it and I return current res. And as you see, this actually runs. It's pretty efficient. You have to run DFS twice though, which is a bummer, but it is what it is. Time complexity is O of n because, but it's like twice. Yeah, that's been it. Thank you for watching. See you in the next one.